Hi everyone, my name is Tarfah Alrashed. I'm a PhD student in computer science at MIT. In this presentation, I will be talking about a tool that we built to democratize access to web APIs. Back in 2017, The Economist published a story where they described data as the oil of the digital era. This is not really surprising, knowing how data can really improve our lives, from researchers and students to support their scientific research, to journalists with the emerge of data journalism. Oil is a great metaphor because, like oil, data also need to be extracted, but from the web. Accordingly, tons of efforts have been made in the last couple of decades to make data open for anyone and everyone to access, reuse, and share. There are many data portals that allow access to thousands of data sets in specific domains like government data, and there are generic search engines that allow users to discover data sets on the web like Google Dataset Search. These data portals and search engines are great. But the web is full of interesting data that goes beyond data sets that can be discovered and accessed through these data portals and search engines. For each one of these websites, there are an unlimited number of queries that can be run on it, which results in an unlimited number of data sets. These data are valuable, but they're definitely not open. Not for everyone, at least. Let's take NASA as an example. NASA is known for their efforts to make their data open for the public. They created multiple data portals, and they work closely with Google Dataset Search to make their data sets accessible through their search engine. But NASA has way more valuable data than what we can find and access through their data portals and search engines. So how can people access this valuable data? In a survey we conducted with more than 100 people, we wanted to understand people's experience with retrieving web data, what sites data that they're interested in, how do they access this data, and the challenges that they face with that. Some people said that they get data manually by copying and pasting the data. This would obviously only work with small-scale data, otherwise it is tedious and a waste of time. Another way that they use to get data is by scraping web pages. Many scrapers do require programming. There are libraries and frameworks for scraping that evolved over time, and there are a number of recent work leverages programming by example, wrapper induction, and programming by demonstration to learn not just from the content, but also from the steps a human demonstrator takes to extract the content that they want. These tools don't work with all websites, and they continue to wrestle with errors inherent in such learned approaches, which can arise from inadequate or inaccurate examples, as well as the frequent changes to web content presentations. While programmers can and do use these non-programmer tactics, they also find ever more sites offering APIs. And compared to scrapers, APIs provide a more reliable way to access and retrieve clean web data, since they do not rely on parsing complex web page structures. Many APIs also offer advanced searches and provide more extensive data that can be accessed by scraping web pages. But they do require programming. Let's quickly refresh on what an API actually is. APIs stand for Application Programming Interface, which is a set of functions that allow programmers to create applications that access data offered by other web services. And although not all websites offer APIs, web APIs are definitely increasing. In 2016, the Programmable Web, which is an API directory, had 13,000 APIs. Now it has more than 22,000 APIs, and most of them are RESTful APIs. In addition, from our survey, 80% of participants wanted data from websites that offer APIs. Let's go back to our example of NASA. NASA does provide an amazing API that allows programmers to write code to access their data, but none of the current aligned data portals and search engines allow easy access to these APIs data by everyone. So what are the challenges of making these web APIs accessible? From our survey, we found a number of obstacles with APIs. In order to access data through web APIs, people need to write code making them inaccessible to non-programmers. And even for programmers, APIs can be hard to learn and use since there is no standard way that they're designed, and there's a great variability in the quality of the documentation. In addition, most modern web services return structured data in JSON and XML formats, which can contain large and complex hierarchies and are difficult for people to parse and paginate through. Given that some web APIs offer more rich data than what we can access through their sites, then what we really want is a query interface that allows everyone to access and query these APIs data and hides the complexity of these APIs. So we did. We built a query interface that we called SNAPI that allows people to query and retrieve desired data from web APIs. In this demo, we're showing how a user using SNAPI can query and filter YouTube Search API to retrieve its data. See, this is great. Building a query interface for a couple of APIs could be manageable, only by programmers, of course. But the reality is there are thousands of web APIs, and these APIs are different. In addition, both programmers and non-programmers need their data. Creating a query interface on top of every API is just unreasonable. A solution to this problem would be to automate the process of generating a query interface on top of every website that has an API, such that everyone, no matter what their technical background is, can query and retrieve the API's data. Well, it is true that APIs are different, but many of them are assembled from a small palette of possible design choices. And the solution is to describe those design choices in a machine-readable fashion, so our query interface, SNAPI, can read that description and use it to generate both a suitable query interface and an appropriate API call. So in the absence of a single standard API, it might be possible at least to create a standard way of describing the many APIs that are in use. Early efforts include WSDL and WADL, both written in XML. More recently, API Blueprint, RAML, and the OpenAPI descriptions have emerged. These API descriptions have been used primarily in two ways. First, to automatically generate API connector code in a variety of languages, and second, to automatically generate documentation describing the API to developers. But while these improve the developer experience, they offer no value to non-programmers who still face the barrier of writing code to access APIs and parse the results. So we designed an API description that we call HAAPI. HAAPI extends the OpenAPI specification that emerged recently as part of the Swagger project. OpenAPI provides much information necessary for SNAPI, but is not sufficient. OpenAPI does not specify information that is necessary for creating a UI to query the API, like human-readable parameter names. And since it is assumed that the code will be integrated into a larger system that uses the API invocations, OpenAPI does not specify information about how to authenticate to the API or paginate to gather large number of results, which we support in our API description. When a web API is described with HAAPI, a query interface can automatically be generated on top of that API. And although writing this description could be easier than writing code, for programmers at least, it does not really guide users, and specifically non-programmers, to describe and access APIs. So we built another tool that we called RAPI that empowers a user to author the HAAPI description for an API simply by filling out a web form. RAPI can guide even non-programmers with little or no understanding of APIs to unpack the necessary information from the API documentation. These three components form ScrAPIr, a repository of HAAPI descriptions and UIs for querying and authoring these descriptions. Using ScrAPIr, any user can first use RAPI to author a HAAPI description of any API. Once this is done just once per API, any other user can use SNAPI to query this API and download its response data. ScrAPIr thus empowers users who want data to standardize and access data query APIs without demanding any cooperation from the sites providing these APIs. In this demo, I'll be showing how a user can access YouTube Search API using ScrAPIr. RAPI guides the user through a number of steps to provide the necessary information to access an API. To begin, the user provides a YouTube Search API URL which can be found in the API documentation. The user must then describe relevant query and authentication parameters in the API. To assist users, ScrAPIr gathers information about common API parameters by searching GitHub and the API Guru description repository and display them in a table. This minimizes the effort of looking for the parameters in the API documentation. ScrAPIr also provides a real-time feedback from querying the API to help the user detect errors. In this case, the user needs to provide a value for the parameter. Another message will show up asking the user to sign up and get the API key value. Then the user needs to enable that API under their Google account. Once the user provides all the required parameters, the response goes green, indicating that the user has successfully accessed the API, and the API returned the results will be displayed on the right pane. The user can then add and remove parameters, and they can hide unimportant parameters from other users. Some APIs requires authentication and/or header parameters. In this example, the authentication is the key that was provided as one of the parameters here. So we can skip this section. From the response, the user can then choose the fields that they want to retrieve by searching for them in the right pane. The YouTube API returns 5 videos by default. To be able to get more results, the user needs to fill out the pagination section, which is optional. The user only needs to provide the parameter name and the type of pagination that the API support. Before publishing the API for others to use, the user can preview their integration. And once the user is done, they can connect that API to ScrAPIr. This API is now connected and another user can access it and query its data. You might think that only programmers can use ScrAPIr to access an API, but as I mentioned in the demo, not only we help populate some of the required information automatically for the user, but we also offer examples and demos for each one of the steps to guide those who are unfamiliar with APIs to understand and find relevant information from the API documentation. One of our non-programmer participants was able to add this YouTube search API in just 7 minutes. To evaluate our system, we first needed to evaluate how many of the web APIs can be described by our API description HAAPI. HAAPI builds heavily on OpenAPI, which has already demonstrated broad uptake in the developer community and makes only limited extensions primarily to cover pagination, authentication, and presentation. We sampled the programmable web focusing on the search category and found that 90% of search APIs can be described by HAAPI, such that SNAPI can query them. Of the 10% not describable by HAAPI, 1 used a different style of pagination and 2 required passing parameters as part of the URL path, which ScrAPIr now supports, but at the time of submitting the paper it didn't, and that improved our coverage of the sample to 97%. We then conducted a user study to mainly answer 2 questions about our system. Can first-time programmers access and query web APIs using ScrAPI faster than writing code, which is the traditional way of accessing APIs? And can first-time non-programmers access APIs using ScrAPI? We recruited 20 participants, 10 programmers and 10 non-programmers, for a 2-hour user study. Programmer users went through 2 sessions, one using ScrAPI and the other one writing code, where we counterbalanced the order of methods. Half started with ScrAPI and the other half started with code, while non-programmers only use ScrAPI. Participants were assigned 1 of 3 APIs or tasks, and these APIs are Yelp, Reddit, and Google Books. All 20 participants completed their task using ScrAPI, and 9 of the 10 programmers completed it writing code. For the programmers who finished both ScrAPI and coding tasks, the average time they spent to complete their task using ScrAPI was 7 minutes versus 27 minutes by writing code, a factor of 3.8 times faster. And the average time that non-programmers spent to complete their task using ScrAPI was 19 minutes, which is faster than programmers writing code. Our tool was able also to guide non-programmers to access those APIs successfully. This chart shows the average time programmers spend using ScrAPI and writing code, and the average time non-programmers spend using ScrAPI on the 3 different APIs tasks. Because we expected that the time spent on the first session would be highly affected by the time spent reading and understanding the API documentation, while it would already be known in the second session, we decided to measure the time spent on documentation separate from the time spent using ScrAPI and writing code. We got some really nice qualitative results. Some of the common threads were that our programmer participants, after trying to access APIs by writing code, really liked how they can easily find and extract data without programming, and how it's much more scalable than writing code. For our non-programmer participants, they really liked how ScrAPIr helped them understand the general flavor of APIs and how it made it easier for them to navigate through accessing these APIs. Like any other system, ScrAPIr has some limitations. An obvious limitation is that it only works with websites that offer APIs. But as I mentioned earlier, web APIs are increasing. Also, some APIs have limitations that we can really control, like requiring users to pay to use them or limiting the number of results user can get at a time. ScrAPIr allows you to add individual API endpoint, but we're currently working on allowing it to support connecting multiple APIs. We're also currently working on building a library for ScrAPIr that allows programmers to access APIs added to ScrAPIr directly into their code, which is something that our programmer participants asked for. Thank you so much for listening, and feel free to try our tool.